So we're on our fourth video dealing with fractions, and in this video we will focus on the multiplication of a fraction and an integer. And if you haven't watched the other videos about fractions and you think you could use the background, check those out. They're in the same playlist. So what does this mean to multiply a fraction and an integer? Well, as a reminder, an integer is any whole number. What is a whole number? It could be 1, it could be 3, it could be 17, it could be -6. So any number that does not involve a fraction. And what is a fraction? Again, as a reminder, it could be a half, it could be a fourth, right? It could be an eighth. Any of these fractional numbers that signify, as we learned in the previous videos, division of a whole number, of an integer, by another integer number. So when we multiply a fraction and integer, we're looking at something like a quarter or a fourth times 3. But we're also looking at what is 3 times a fourth. Now, we know from the commutative law that these two operations are equal. So 1/4 times 3 is equal to 3 times a fourth. But I will convince you of this. We will look at both options and we'll see that they are the same. So let's start with as usual, with an example. Let's look at a square, for instance, a chocolate bar, and let's divide it into 4. So we have 4 fourths here, right? This is a fourth. This square is a fourth of the whole bar, as are these two squares, right? So we've divided it into 4, and we have 1, 2, 3, 4 different squares that are each a fourth of our chocolate bar here. Now, so one of these is a fourth, but we want to look at 3 times a fourth. So we're looking at, let's use some color here. Let's look at this fourth. Let's look at this fourth, and then let's add another one. And so we get 3 of these squares, or 3 of these fourths of the chocolate bar. So when we take 3 times a fourth, what we get is, I'll draw this out, we get something, right, that looks like that, because we have 3 of these where we've removed this one. We didn't take the fourth one. Okay, so we have this amount of chocolate. Now we can organize this. Let's move this square up here, so we get 1, 2, that amount of chocolate altogether. Now, what do we get when we look at this case where we have a fourth of 3 bars of chocolate? Well, let's take our 3 bars, right? And we'll take a fourth of each one of these bars, right? So these are 3 bars, 1, 2, 3. And in each one, I'm going to take only 1/4. Okay? So we're going to add these up, right? Because we have 3 of them, and we're taking a fourth from each one, right? So it's a fourth from 1 plus 1 plus 1, right? 1 plus 1 plus 1 is 3, and that's what I drew here. And so now we take this one, plus this one, plus this one here. And this equals, again, 3 squares. And so it's exactly equal to what we got in that first case where we looked at 3 times 1/4. So what we see is that when we multiply a fraction and an integer, we can change the order, and we get the same value. Now let's write this in a slightly more general form. Say we have an integer. Let's use the common notation n for an integer. And let's take a fraction, 1 over m, okay, where again m and n are integers. So if we say n times 1 over m, that'll equal to 1 over m times n, where here n can be either number of fractions that we add up or number of wholes, right? So that would be in this case, while in this case it's the number of fractions and they're equal. Another way to write this, though, as we saw previously, is when we take n times 1 over m, we have n over m. So let's write this out again. N times 1 over m equals 1 over m times n, and these both equal n over m, which is just taking n wholes and dividing into m. Okay, so that was a more general way of saying the same thing we saw in the example. But to drive this home, let's look at one more example just to make sure that we feel comfortable with it. Let's look at an example that'll challenge us a little bit more. Let's look at, say, a cup of water, okay? So we have a cup of water, and we will not fill it up all the way to the top. So this is the top, but let's say that we are able to fill up to 2/3 of the cup, okay? So we've divided the cup into 3, and we fill it up 2/3 of the way. So this is 1/3, this is another third, and we leave the last third empty, okay? Now let's say that we are with our friends and we're giving out water to a bunch of, say, 5 kids. Okay, so 5 kids are going to drink. That means we need 5 cups. And we're going to fill each cup up to 2/3, right? That is just 2/3, right, of the cup. So now, how much water do we need? Well, we'd like to do 5 times 2/3, right? That's the amount of water. That's the total amount of drink or water that we need for all 5 kids. So what is 5 times 2/3? Well, in the previous examples, we always took a fraction that had in its numerator 1. But in this case, we're taking a numerator 2. So 2 is not 1. So it's just a little bit more challenging. But you'll see it's exactly the same thing. When we do 5 times 2/3, we do exactly what we did before. We say we're going to take 2/3, right, plus 2/3 plus 2/3 plus 2/3 plus 2/3. Now, we've seen before that 2/3 is just a third plus another third, right? When we filled up this cup, we said we're going to fill a third and then yet another third. So that's how we got to 2/3. And that's what we saw in the examples where the numerator is 1. When we add them up or multiply them by 2, we're getting we're taking twice a third. So let's write each one of these as a sum of 2/3. Okay, it's a little bit cumbersome, but that was meant to be a 3. But it's worth looking at this in detail. So this is the first 2/3, this is the second 2/3, this is the third 2/3. Now we're getting to the fourth 2/3, and finally to the fifth 2/3. Now, if we look at how many thirds we have here all together, and we can open these parentheses because we have all the same operation. It's all sum, so we're allowed to open these parentheses. We get a third plus a third plus a third, plus a third, plus a third, plus a third, and just 4 more of these. So I've just copied them all down. And now I see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 thirds. So I can write that as 10 times a third, right? Which is equal to 10 thirds. I can also write this as a third times 10 because we are allowed to change the order of operations. Now, if we look at this carefully, at this 10 thirds, and we look at our initial problem, what we learn from this is that 5 times 2 thirds is equal to 10 thirds. That's interesting because 5 times 2 is equal to 10. What does that mean? It means that when we do 5 times 2 thirds, we can write it as 5 times 2 over 3. That is our new fraction. And 5 times 2 is 10, so we get 10 thirds. Can we write this in a general format like we did previously? Yes, we can. If we have n times, let's write this as a new fraction as p divided by q, right? We can also write this as n times p divided by q, or as p divided by q times n. Here, I use the dot, but we should really use the multiplication symbol. So this was a review of how we multiply a fraction and an integer. To recap, you're allowed to change the order, and basically when we're multiplying an integer and a fraction, we can multiply the integer by the numerator of the fraction. Remember, this is the numerator, and this is the denominator. And if these definitions are not fresh in your mind, please check out the other videos in this playlist, starting from the first one, Fractions 1. It'll help you get up to speed and understand this video. So thanks for joining me, and we'll continue in the next video with more fractions. Bye for now.